Hello brothers and sisters, this is Mishako H, and in the last few videos we've been looking about the basic concepts of Java. We've done a lot of installations. Now in the next few video tutorials we will examine three of Java's most fundamental elements, which are data types, variables and arrays. As with all modern programming languages, Java supports several types of data. You may use these types to declare variables and to create arrays. As you will see, Java's approach to these items is clean, efficient, and cohesive. The first thing that you must understand is that Java is a strongly typed language. First, every variable has a type, every expression has a type, and every type is strictly defined. Secondly, all assignments, whether explicit or via parameter passing in method calls, are checked for type compatibility. There are no automatic conversions of conflicting types as seen in some other languages. So the Java compiler checks all expressions and parameters to ensure that the types are compatible, and if there's any mismatch or errors, the compiler will prompt you about the errors, so it cannot automatically convert. So in Java we have what we call primitive types or simple types. So Java defines 8 primitive types, which are byte, short, int, long, char, float, double, and boolean. So the 8 types can also be grouped into 4 groups. So the first group is a group made up of integers, and this group includes the byte, the short, the int, and the long, which are for whole-valued sign numbers like 1, 2, 3, 4, 5, 6, and so on and so forth. And then the next group is the floating point numbers, which includes float and double, which represent numbers with fractional precision. For example, 0.25, 0.27, and so on and so forth. Another group, which is the third group, is the characters, which has char in it. This represents symbols in character set, like the letters and the numbers. So the last group is the boolean, used for representing true or false values that only have two options. For example, yes or no, true or false, but usually it will return the value true or false. Although Java is otherwise completely object-oriented, the primitive types are not. They are analogous to the simple types found in most other non-object-oriented language. If you came from C++, these primitive types will just be similar with what you learned in C++ or in other languages, okay? So let's begin by looking at the first type, which was integers. So Java defines 4 types, which are byte, short, int, and long, as we have mentioned, and all of these are signed, positive, and negative values. Java does not support unsigned, positive only integers. This width of an integer type should not be thought of as the amount of storage it consumes, but rather as the behavior it defines for the variables and expressions of that type. So let's first look at the byte primitive type under the integers. The byte is the smallest integer type. This is a signed 8-bit type that has a range from -128 to +127. Variables of type byte are especially useful when you're working with streams of data from a network or a file. They are also useful when you're working with raw binary data that may not be directly compatible with Java's other built-in types. So byte variables are declared using the word byte, and the word byte must all be lowercase, B-Y-T-E. That's the byte keyword. Short is a signed 16-bit type and has a range of -32,768 to +32,767. So it is probably the least used Java type. The next one, which is the most commonly used, is int. So it is a signed 32-bit with a range of 2,147,483,648, that's negative, to positive 2,147,483,647. In addition to other uses, variables of the type int are commonly used to control loops and to index arrays. So the next is long, and long is assigned 64-bit type and is useful for those occasions where an int type is not large enough to hold the desired value, because I gave you the range of the int. If the number to be held by the variable is bigger than the range I gave you, then it means you need something else, for example the long. The range of a long is quite large, making it useful when big whole numbers are needed. So we'll write a program to demonstrate the byte, the short, the int, and the long. So let's head over to Eclipse, which we set up in the last video, and we'll write the program. So now we are going to demonstrate our program in Eclipse. Okay, a program to show us about the int, the short, the byte, and the long. So basically I told you in the previous video that when you're making a project, you click File and navigate to New. Okay, and you be making note of these shortcuts, because you can decide to say Alt Shift N and it will open this window, and then we say Java project. So we will call our Java project data types, because we'll be doing data types in this one, and click enter. So for this one, you click the drop down, and then in the src folder you right click and say new Java class. Now as I mentioned earlier, you'll be typing your code, but because I need to save time, I'll click to generate the public static void main. That's the main method, and I'll give the name integers data types. Okay, I'm sorry, I placed that in the wrong place. It should be in the name. Okay, so I'm just using a default package, but you can make your own package. That's why they are discouraging the use of default package, and then I click finish. So see, the name is default package. Had you made your own package name, it would exist here. So this is our class, and this is our main method. You see the coverage of the main method. Alright, so what we're going to do is demonstrate the byte first of all. So to declare a byte variable, you just type the word byte, the keyword, and what you want to give it. For example, BA, that's the variable name, and you can just do that, or you can assign some value to it. So I can say is equals to 4 and semicolon, or I can just leave it that way, and then later on I'll just come down here and say BA is equals to 4. Okay, so if you like it this way, then you can just declare as many bytes as possible. So I can declare another one, let's say BB and BC. So BA is equals to 4, BB is equals to, let's say 15, and let's go to BC is equals to, what do we give it? Okay, is equals to BA times BB. So BA, can we do, or even plus? Okay, BA plus BB. All right, so as you can see, there is an error, because usually Java is used to the integer, the int type. So we need to cast the byte to mean that we are doing with the byte. Okay, so this is called casting, byte casting. Okay, so basically the next thing we need to do is to print BC and see what will come out. So as I told you earlier, you can just type cout and press control spacebar. It will do the autocomplete for you, and then we will put byte BC is equals to, and then go out of that and put a plus sign, and then put our variable. No, so what we're doing here basically is we're making a string that will display as byte BC. That's why we have the colon, the quotation marks, and then the plus is to add this BC, or the result from this variable, with the string, so that when you run it, it will display byte BC is equals to then the result of BC. So basically I want you to keep in mind the structure of the class. The class fences off everything, and next is this one. So I'm going to run our program. So what you do, you save. After you save it, you click this button to run it, and basically you'll see byte BC is equals to 19. All right, So if we do the same thing for let's say short, okay, and then for this one we have to change it to short, okay, and if we do the same thing and then save it and run, it's still the same thing. Our short BC is 19, so 4 plus 15 is definitely 19. And then for int, you won't need to do this casting. So if I remove this, I have the error, and change this one to int, because Java is used to int, then our int is, okay, so you run it and you get it, int BC is still 19. All right, so you can see it's just depends, the sizes are only the problem. Okay, so for example, if I was to use the first one and the number is out of the bound or out of the number allowed, then we'll get an error. I'll demonstrate that when with the long variables. All right, so the next thing I wanted to mention is, earlier on I said that Java is strongly typed. For example, if I type int with capital I, instead of guessing and correcting it for me to say that I meant int, it will make it an error, and then I'll get several suggestions, and I'll have to specifically use the keyword that's made for that, or that's intended for that purpose. All right, so let's head over to long. So I'll just give it a space, and then I'll declare long. Let's say we have something called light speed in miles per second. We have something around 186,000, okay, and we have also long number of days is equals to, so this is my other way of declaring. I'm declaring directly and assigning the value instantly. So instead of doing this first for all the variables and then coming to assign them later the way I did in this one, I'm just assigning directly. So long number of days is equals to, let's say we need to calculate the light speed for 25 days, and then long let's say seconds is equals to, we have the number of days. How do you change days to seconds? Times number of hours times number of minutes times number of seconds. Okay, so we already have our seconds, and then we have our long speed, okay, is equals to light speed times the number of seconds, so that we'll have the speed in seconds. So if I was to go out and print the speed, okay, so let's go cout space, and then let's say the variable you want to display the speed is that one, and then plus, now let's say speed. Okay, so let's see what our speed is. I've already saved by using the shortcut Control S, and if I run it, you see the speed is displayed in full. Now let's change this speed to int. Okay, so because our other variables are in long like this one, we need to cast to add this cast, okay, so that it will accept to convert it to this int. So if we print, we get negative. This is showing that it's out of bound. We are not able, the answer is longer than what the int can handle. So that's the use of the different types of, you know, from int, long, short, and byte. Okay, so when one is small, it can be used to, a bigger or a better size can be used to handle the value. So that program demonstrated the use of byte, long, short. So please type it, mess around with the program and play with it, and see you in the next video, where we will see what we call integer literals. So we will be introducing things like hexadecimal, binary numbers, and other things. Okay, so thank you so much for watching my video, and see you in the next video. Goodbye.